Good morning. My name is Professor Subramaniam Ganesan. I am from Oakland University, Rochester, Michigan, USA, United States of America. My presentation today is on embedded AI for education. So I have a website, www.saccs.oakland.edu/Ganesan. You can go there to get more information about me. So embedded AI or embedded artificial intelligence will enable new, inexpensive, low-power AI solutions that are not possible using cloud-based AI technologies alone. The edge AI chip market is growing much faster than the overall chip market, and then it is estimated to be nearly 1.5 billion chips in 2024. The embedded AI requires knowledge and skills of multiple disciplines. It should be starting with traditional embedded system design, data science, machine learning, signal processing, and then specialized software tools and frameworks to develop embedded AI applications. So some of the applications are on fault detection, diagnostics, and fault elimination, and for monitoring machines and so on. Not only that, it has wide applications in robotics, medical, patient health, and general intelligence support. And also the important one is personalized education for students. AI plays an important role in learning. AI enhances the personalization of student learning programs and courses. It promotes tutoring by helping students to improve their weak spots, sharpen their skills, enhances anytime, anywhere learning opportunity. This is nearly a $20 billion market, and it reduces the burden on the teachers, but then it shifts the role played by the teacher in repetitive activities. So AI supports teachers. AI can augment the learning experience of students, and then it makes the life of teachers a little easier. It takes over the repetitive activities like grading and sending messages to the students and so on. It tracks the student progress, personalizes the learning. Intelligent students can be given more advanced topics to learn, and the less intelligent students can be given at a slower pace the same material. Making education more accessible at a low cost is the major impact by AI. Every student gets a digital device like an embedded system or a tablet with a special sensors, which tracks the progress, trains the student, uploads the result to the cloud for analysis, and then it provides the next level of lectures to the student directly to the device. So for example, you can identify the attention deficit children and teach them in a different pace, slowly, so that they learn all the material that are needed. So there is a fear for AI. If AI is applied for school educations, humans will get more assistance from the machines, and it will shrink the brain's capabilities. No, this statement is not correct, because there is no such thing that will happen to the brain, and the brain will always seek for easier tasks this tool, the calculator, or their own brain. Otherwise, it will go to the cloud. So the EAI has a number of tools. One is the TinyML. It is a field of applying machine learning technologies to embedded AI. And then, embedded AI is a resource constrained device. That is, it has a low power. It has to operate from a battery, and then it may have a limited memory. So we need to use the correct trade-off to make decisions on AI processing, whether to do the processing at the device or at the fog or at the cloud. Fog is the edge computer that is nearer to the device, and then it goes through the network to the cloud. So what is embedded AI? Embedded AI is the application of machine and deep learning in software at the device level, that is nearer to the student or nearer to the activity or in the manufacturing plant at the machining device, a machining machine. So software can be programmed to provide both predictive and reactive intelligence based on the data that is collected and analyzed. So this shows a typical picture where you have at the bottom sensors and the devices like the PowerPoint, the iPad, or the various other machining device or the robots. Then it goes to the edge. From the edge, it is connected through the network to the cloud, and all the analysis are done at the cloud. AI is more available and more powerful today. The term AI was coined in 1956, but it has become very popular today because of the increased data volumes and increased advanced algorithm and improvements in computing power and the storage. So there are many advantages for AI. AI drives down the time taken to perform a task. It enables the execution of complex tasks. It operates 24/7 without interruption, and AI augments the capabilities of different persons. The hardware used for embedded AI is mainly consists of CPU, central processing unit, graphical processing unit, and field programmable gate arrays, and multi-core chips, and application-specific integrated circuits, ASIC. There are AI chips. AI chips provide power efficiency and high performance for AI applications because of their heterogeneous computing abilities. AI chips are tens or even thousands of times faster and more efficient than the simple CPU for either training or for inference of AI algorithms. For example, Intel has the AI chip, which is called NPU, which is a neural processing unit, and it is very fast and it consumes very low power. GPUs, graphical processing units, can perform multiple simultaneous computations. It has thousands of arithmetic logic units inside this. It is like a multi-core chip, and they are great at computing complex mathematical data like neural networks. And they are 3 times faster than this simple CPU. There are AI chips for ANN, artificial neural network based applications. ANN is a subfield of AI. ANN is machine learning approach inspired by the human brain. There is also machine learning applications using such networks, and it is called deep learning. Deep learning has 2 main use cases. One is for the training and also for inferencing. There are chips for like MAIX, SpeedX, SPEED. It's purpose-built module designed to run at the edge AI applications. So there are very many supporting chips. And for example, if you have the artificial intelligence, we need to build systems that act like humans. So that is our major goal. AI algorithms development depends on the application and the hardware. These algorithms extract the desired information directly from the sensor data. They encompass the full range of machine learning methods like linear regression, neural networks, random forests, and hidden Markov models to come up with a solution. So the deep learning is a subset of machine learning, and practical examples of deep learning are virtual assistants, that vision for driverless cars, money laundering, and so on. There is also GPU acceleration. Deep learning relies on graphical processing unit acceleration. NVIDIA is a company which delivers GPU acceleration. This shows a board from NVIDIA, which can be used for self-driving cars, which is very powerful, and it allows easy computations. And also there are cheaper NVIDIA Jetson cards that are less expensive, can be used in the lab environment and for most of the simple applications. CNN is a convolutional neural network, is a type of neural network which is widely used for image and object recognition and classification. And in conclusion, embedded AI applications need multidisciplinary approach. We start with a huge amount of collected data, and a good amount of software libraries and algorithms are already available. More application dependent documents are needed. A good amount of AI hardware are available. Autonomous driving and automotive industry uses AI, so it is going to reduce the cost of AI applications. AI has a huge potential in education in schools and also in self-learning for adults. So with this, I conclude my talk. Thank you for patiently listening. You can reach me at ganesan@oakland.edu. Thank you.